This is a demonstration on transistors for National 5 Physics. Here is a transistor. May not look like much. It's a small silver capped thing, but they changed the world. They made it so computers no longer had to be the size of buildings. They're something that can now fit in your phone. So I'm going to demonstrate how they work and why they're so important. So here's a very similar setup to last time, except this time I've got this component. This has got a transistor as part of the circuitry. And you'll notice hopefully something happened to this LED as I change the resistance of R2, increasing the resistance across it. The LED turns on. The LED is connected to the collector on the transistor, whilst this terminal is connected to the base, and this terminal is connected to the emitter. So let's attach a voltmeter and figure out what's going on. So what we have here is our voltmeter connected across R2. As you can see, it's currently reading 0.35 volts, but let's increase the resistance here, increasing the voltage, and see what happens to the LED. The LED has come on, and we're reading 0.62 volts. You may remember in the last video I used 0.7 volts as an example across here. Well, that wasn't a coincidence. That is the switch-on voltage of a standard transistor. This one's reading 0.262 volts, probably because this transistor is quite old. Older than many of you watching, I would suggest. You now hopefully begin to see why it is important to be able to tune your electronic equipment, so that you can actually get this transistor to turn on at exactly the point you want. Here's a similar setup to what I showed in the previous video. Got an LDR down here, and a variable resistor tuned so that when I stick my hand across this, the LED turns on, as the voltage across R2 is reading 0.8 volts. That is higher than the switch-on voltage for the transistor. I remove it, the resistance of this decreases, and the LED goes off, because the voltage here is no longer above 0.7 volts. At first this doesn't seem particularly useful. You can switch on a very low power item, but not much else. That's where a relay comes in. So here we have the same circuit as before, except this time I've added a relay. And you'll notice if I cover the light, you can hear a click. That noise is two contacts in the relay closing to act as a switch. That means that we can now use these two contacts here to run a much higher voltage circuit. So here we have a scenario where our relay is connected to a high power bulb, 36 watts. This small circuit here wouldn't be able to drive such a thing. This bulb is currently attached to a power supply that you can't see. So what happens, let's say at night time, getting dark, want the street lights to turn on. And there we go, nice bright bulb. Comes morning again, the lights go off. So hopefully you can see why these little things are so important. They're in absolutely everything you own that uses electricity. They've created the modern world.